questions, if any. If you are not asking the question, then I'm assuming that okay, you are getting the things. So feel free to ask wherever you have doubt. And now we will go on to the next algorithm, insertion sort. Now this algorithm is bit tricky in the sense not very common that students learn that. And that is the reason we want to see it one by one. Ashraf saying that please summarize important point to remember for the algorithm at the end. Ashraf, in my opinion, there is nothing important as far as this such a basic algorithms are concerned. Like your algorithms are pretty simple. The time complexity is that we are calculating. So only thing that you need to remember is basically the philosophy of the algorithm that we started at the start, that why it is called a bubble sort, and at the end, what is the time complexity of that. So किसी भी algorithm में इससे ज्यादा special कुछ नहीं होता. और algorithm is algorithm. So algorithm में more important, less important, I personally do not see anything that is like more important. अब I variable लेना है, J variable लेना है, temp variable लेना है, swap variable लेना है. That's it. Now you cannot keep discussing that this line is more important, this line is less important. हाँ, wherever ऐसे जब algorithm आएंगे, जब उतने बड़े algorithm आएंगे, definitely we can discuss that as well. But I believe these algorithms are pretty simple. If you need anything explicitly to be asked, feel free, go ahead. We will discuss that. Okay, I'm just starting with and talking about insertion sort. And you know, teaching insertion sort is not what I say. The teaching insertion sort is something very easy, provided you know in advance what is insertion. So I'll just like to keep insertion sort aside for some time. Insertion sort aside for some time, and I want to focus on something called as a insertion technique. I repeat once again, I want to focus on something called as a insertion technique. So what is the insertion technique? Let us just go ahead. Let us first understand what is insertion technique. Once you understand insertion technique, then we will discuss the insertion sort. I repeat once again, I'm not teaching you the insertion sort. I'm only talking about the insertion technique first. What is insertion technique? Let us talk about that. Once you understood insertion technique, then let me know. Then we will move and we will discuss about insertion sort as such. I hope you are ready. So let's say that this is my array at the initially. This is my array initially, and let us get started. Now tell me, is this array is sorted? Is this array is sorted? No. Is this array is almost sorted? Is this array is almost sorted? See it very carefully. You'll find that only one element is unsorted. अगर आप लोग इस एक एलिमेंट को बाजू में निकालते हो, you find that your rest of the array is well sorted. Except to rest of the array is almost sorted, right? And this is a technique that I am trying to focus. मैं फिर से बता रहा हूँ, मैं इंसर्शन सॉर्ट नहीं पढ़ा रहा हूँ, मैं इंसर्शन टेक्निक पढ़ा रहा हूँ. इफ यू कुड अंडरस्टैंड इंसर्शन टेक्निक, learning insertion sort is matter of 2 minutes. So please focus on to that. So what the logic is, a logic is very simple. The element which is not sorted, sorry, the element which is not sorted, you take it out. You take it out, you take it in some temporary variable. And once you take in a temporary variable, you start comparing it with all previous elements. Now you start comparing with the previous element, you start comparing it with 8. You compared with 8, you realize that 8 is greater than 2. You please shift it. I do not say swap it. I said shift it. Shift it to the next position. You compare it with the previous element. You compare with previous element. Again, you find that 6 is greater than 2. 6 is greater than 2. Shift 6 to the next position. Again, you continue further. You find that 4 is greater than 2. 4 is greater than 2. Again, you shift it. You continue further. You find that 3 is still greater than 2. 3 is greater than 2. You shift that. And again, you compare with 1. 1 is a 1 is not greater than 2. If 1 is not greater than 2, what exactly it means? It only means that this is the ideal position for the 2. So जहां कहीं पर भी आप लोग 1 है, उसके बाद वाली लोकेशन पे उसके नेक्स्ट लोकेशन के ऊपर you want to put your 2, and this is nothing but I call it the insertion technique. I hope you got that. I'll just go through it once again. I'll go through it once again. Please note, this technique is to be followed only when your last element is unsorted. If your whole array is unsorted, this technique is of no use. This technique is of no use. So I'm just going ahead and I'm saying that let us take a temporary variable. This is a temporary variable. I just taken this, and you start comparing it with all previous elements. You start comparing it with all previous elements. You find that this element, let's say हम लोग इसको j कहते हैं. So jth element is greater than 2, greater than 10. So shift this. You compare with the previous one. 6 is greater than 2. You shift it. Again, you go ahead. 4 is greater than 2. You shift this. Again, you find 3 is greater than 2. Shift this. Finally, you go over here and you find that 1 is not greater than 2. 1 is less than 2. If 1 is less than 2, what I'm saying, I simply say that this position is ideal position. This position is kind of ideal position for 2. That is after 1. Is this clear? Wait, I'll take up one more example. I'll take up one more example. This is like one example I already repeated twice. I'll take up one more example. With one more example, see it carefully. Now my example is a bit different. Example is a bit different, and I would love to draw even the indices there. I'll just draw some of the indices there. This is index 0, index 1, index 2, index 3, index 4, and index 5. This can be even said like index -1. Correct? So this is kind of array that I have got. Again, I believe that this array is still almost sorted. If the array is almost sorted, what to do? If the array is almost sorted, what to do? You take out this element. You take out this element, and as you take out this element, you start comparing with all elements before that. All elements before that, you find that 8 is greater than 1, shift it. Good. 6 is greater than 1, shift this. 4 is greater than 1, again shift this. 3 is also greater than 1, again shift this. 2 is also greater than 1, again shift it. But now you find that there is no element to compare before that. Now there is no element to compare before that. It also means that this element is probably the smallest element, and I should insert that element after this. After this is after -1. So in short, I should be putting it at the 0th location. I'll repeat it once again. This is where things are, and I'm saying that you start comparing. You take the last element out. This element is unsorted. If this element is unsorted, please pay attention. If this element is unsorted, you take this element out. Taken this element out, you start comparing with all elements before that. All elements before that. So you start comparing with this. What is that? 8. 8 is greater than 1. So shift it to the next location. 6 is greater than, oh sorry, I can say z minus minus. 6 is greater than 1, you shift this. You continue further. 4 is greater than 1, again you shift this. 3 is also greater than 1, again you shift this. 2 is also greater than 1, again you shift this. Please note, again if you are saying minus minus, again if you are saying minus minus, you are going with like a -1. Now j becomes actually -1. Now what you need to do, I said that in this particular case, अब comparison मत करना. अगर आप लोग comparison करते हो, you will get array index out of bound exception. I do not need a comparison to be done over here, but in this particular case, I can say that 1 can be inserted at this location. So this seems to be a right position. So after -1 is right position to be added. Is this clear? And if this is clear, how you convert into the code? Oh, that is something that I need to worry about. The insertion technique, how I can convert into the code. Oh, how I can convert into code? I'll just go ahead. मैं वापस से insertion sort नहीं पढ़ा रहा हूँ. मैं सिर्फ इंसर्शन बता रहा हूं. Void, let's say insertion. I'm just writing only insertion. Go ahead. And then I'm saying that I'm assuming that the last element in this particular case, I said that last element is nothing but क्या कर रहे थे हम लोग? It is an important element or like unsorted element. The last element is unsorted element. I want to take it out. So how do you do that? So I can simply say temp is equal to ARR of, how do I get the last element? I believe it is quite simple. ARR dot length minus 1. So this is nothing but I'm getting the last element. Then what I want to do, I want to compare with all elements before that. Oh, all elements before that, you continue further. J is equal to, if from where you started with something called as ARR dot length minus 2, correct? You started with ARR dot length minus 2, a minus 1 तो वैसे भी last element है, उसके पहले वाला element. And then j is greater than or equal to 0, j minus minus. So what you are doing is that you are continuing comparing with all elements before that, all elements before that. And then each time, wait for a minute, each time you find that jth element, have a look at this. Each time, if the first condition is true, then and only then I'm going on a second condition. If you find that AR of j is greater than 10, if you find that ARR of j is greater than 10, then what do you want to do? Oh, I want to just shift it. So ARR of j plus 1 is equal to ARR of j. This is what you do the shifting. Jth element, you want to put it under j plus 1th element. Jth element, you want to put it like a j plus 1 element. That is what all we are doing. Okay, good. And this way, see, now your condition will be false in either one case. Either a case where ARR of j is not greater than 10. Either a case where ARR of j is not greater than 10. Possibility number 1, and possibility number 2 where j becomes kind of minus 1. Please note, there are two possibilities just above we have discussed. So there are two possibilities. Either you find a number which is less than 2, possibility number 1, or your j reach to something, let's say minus 1. You reach to the minus 1 index. Either case, a logical AND है. If any one condition is false, you are going to come out. But if you come out, what do you want to do? I want to just add the element onto the next position. I just want to add the element onto the next position. I just want to add the element onto the next position. So what exactly? It is very simple. All I want to say is that ARR of j plus 1 is equal to 10. This is nothing but a insertion technique. I hope you got the point. I'm just quickly going through the code once again. Please pay attention. Please pay attention. So what I'm saying is that I was considering in a scenario where the last element is unsorted. In a first example over here, I said that यहाँ पर 2 unsorted था. I repeat once again, do not ask me the question on a sorting. जो अभी मैं पढ़ा रहा हूँ, let us first focus on that. First understand that, then I will teach you insertion sort. And once you understand insertion sort, if any questions are pending, then ask it. बहुत आगे वाला मत सोचो, ज्यादा कंफ्यूज हो जाओगे. Go step by step, right? Wait, hold on. मैंने कहा ना अभी जो मैं पढ़ा रहा हूँ, it will be really good if you focus onto that. What is the focus? अभी मैं insertion technique पढ़ा रहा हूँ. You learn insertion technique. Any question regarding insertion technique, do ask. And then how insertion is related to insertion sort? Oh, that is a different question that I will come down later, right? मैं शायद मैंने कल भी आपको बताया था. डेटा स्ट्रक्चर में सबसे बड़ा प्रॉब्लम ये है, distractions is like a biggest problem. So you start teaching one topic, students are thinking of the next, and then by the time you reach to the next, they have not understood the basic topic, and then they are confused. So this is very complicated. I always suggest, I always recommend, let the topic be completed, and then you have any questions, yes, you can definitely ask. Or if you have a question related to what is going on, do ask at that moment. करेक्ट? आगे वाला मत पूछो, होल्ड ऑन, हैव पेशेंस. चलो हम लोग आगे जाते हैं. हम लोग कहाँ पर थे? तो मैं आपको यहाँ पर बता रहा था. इन अ फर्स्ट एग्जांपल, अरे क्या चल क्या रहा है? In a first example, I said that this element, something is going wrong with this. Yeah, no problem. What happened to the key? Ah, so in the first one, what you say is that in the first one, what you say is that this element is greater. This element, sorry, this element is unsorted. You take out this particular element and you start comparing with all elements before that. You start comparing with all elements before that. Finally, you reach to the element which was smaller than that. Moment you find the element which was smaller than that, you just inserted the element after this, like a first pass. And the second one, in the second case, I said that I tried to find out that one itself, the smallest element itself was unsorted. वो at the end था, वो at the end था. I just go back. I compared with all element before that. I compared with all element before that. I didn't find a single element. Finally, I reached to the last index, like -1. Last index meaning even before last index, -1. And then I found that okay, there is nothing to compare. So we added an element after that. We added the element after that. What we have done in a code? In a code, I just started with ARR dot length -1. So this was nothing but my last element that I have considered, not a problem. Then you start comparing with all elements before that. A before that matlab length -2 se leke j is greater than or equal to 0, and every time I'm doing j minus minus. However, by the you want to repeat this full loop. If ARR of j is greater than 10, ARR of j is greater than 10, then jth element I want to shift it to j plus 1. Jth element I want to shift it to j plus 1, and this will continue. This will continue till what? In two cases. Either you find the element, either you find the element which is less than temp, either you find an element which is less than temp, and if you find the element less than temp, you just come out of the loop and you try to add the temp, the element ahead of this. This is like a one possibility. The second possibility I'm saying, if there is no element smaller than temp, if there is no element smaller than temp, I simply say j is greater than or equal to 0, or condition is, if this condition is false, if at all this condition is false, what will happen? Oh, nothing much. Then in that case, probably j is equal to -1, and again you come out, and you see that oh, the elements you are trying to add at j plus 1 is equal to 10. Is this part is clear? Is this code is clear to everyone? Right. If this code is clear, it means that you people have understood well. You people have understood well what is insertion technique. And now if I understood insertion technique, then my next question is that, sir, वो insertion technique ठीक है कि when your only one element is unsorted, you are saying that it is very easy. But what if my entire array is unsorted? What if my entire array is unsorted? I do not know. Deepak is having question. Why j is equal to arr dot length? I guess Deepak, I told you that we want to take one element out. Deepak, please pay attention. This is for you. You want to take one element out. ये जो आपका last element था, it was of length -1, isn't it? It was like a n minus one location. It was n minus one location क्योंकि आपका array का indexing n minus one तक ही होता है. And now I want to compare all elements after that. If you are comparing all elements after that, if you are comparing all elements after that, then I guess it is n minus 2, isn't it? Deepak, is that clear? If this is n minus 1, obviously this has to be n minus 2, right? Sandeep, what do you want me to repeat? Last part, which last part here? You're talking about a code? You're talking about an algorithm? Code, no problem. Be specific, it will be really good, instead like we wasting time. Going ahead, so I'm saying that I want to take the here I'm assuming that I'm trying to tell you the insertion technique. With the insertion technique, what I'm saying is that if last element is unsorted, I want to put it in its right position. That is the idea. And if that is the idea, I do begin from this saying that temp is equal to ARR of n minus 1. N minus 1 क्यों? क्योंकि वो last element है. So I simply said length minus 1, which is the last element. I taken it in a temporary variable. I taken a temporary variable. I want to compare all elements before that. All element before that. अगर आपका लास्ट एलिमेंट n माइनस वन पे होता है, कॉमन सेंस आपका सेकेंड लास्ट एलिमेंट n माइनस टू पे होगा. सो फ्रॉम देयर j is greater than equal to 0, condition is true, then j minus minus. So I'm just making a loop going in a backward direction. Loop going in a backward direction, I'm checking j is greater than 0 at the same time if that zth element is greater than 10. If that zth element is greater than 10, then what I need to do? I need to just shift that zth element. I need to just shift that zth element to the next location. And next location, z plus 1th location. So zth element, I want to shift it to the next location. Zth element, I want to shift it to the next location. Zth element, I want to shift it to the next location. This is what all I need to do. अल्टीमेटली ये लूप फॉल्स कब होगा? देयर आर टू पॉसिबिलिटीज. दोनों पॉसिबिलिटीज के लिए दो अलग अलग डायग्राम मैंने आपको दिखाए थे. एक पॉसिबिलिटी दैट यू आर सेइंग दैट दिस एलिमेंट इज काइंड ऑफ अ this element is unsorted, you're taken it out. You started comparing with all elements and you found a variable or you found an element which is smaller than that. When you say that this element is smaller than that, you are also saying that this condition is false. And if this condition is false, what do you want to do? Obviously, you want to come out of the loop and simply say error of j plus 1 is equal to 10. तो 1 के आगे वाला जो लोकेशन है वहां पर मुझको 2 ऐड करना है. This is what all we need to do. We have done that. But the second case also I told you कि what if the 1 itself is unsorted? 1 itself is unsorted. You taken out 1. You taken out 1. You compare with all elements previously. As you compare with all elements previously, you do not find any element which is smaller than that. Ultimately, j reach to the minus 1. If j reach to the minus 1, j reach to the minus 1, I want to add the, still I want to add the element after that. So again, I'm just going back and I'm saying that in this particular case, your j is greater than equal to 0, the condition is false, you come out of the loop because j becomes minus 1 and then AR of minus 1 plus 1, that is 0, temp is added. Is that clear now? Done. No problem. Now we will go ahead. Now we will go ahead and we will see what is the insertion sort then. मैंने कहा ना मैं अभी तक आपको इंसर्शन पढ़ाई इंसर्शन सॉर्ट नहीं पढ़ा रहा था. नाउ लेट मी फोकस ऑन इंसर्शन सॉर्ट. And now please pay attention. Now please pay attention. Now it's insertion sort. If you are worrying about insertion sort, I said that now at this moment, focus, listen carefully. Do not focus onto the whole array. Do not focus onto the whole array. You just focus on an array of 2 elements only. Let us hope that my array is only of 2 elements. If I say that array is of 2 elements, which is the last element in this case? If I say that array is of 2 elements, which is the last element? Yes, last element in this case is 4. I simply say that you consider this as your last element, this as your last element, and if this is your last element, you start comparing it with all elements before that. What I said, if this is the last element, you start comparing it with all elements before that. So what I'm saying is that you consider that your array is now limited. Consider that your array is limited and your array is of only 2 elements. If your array is only of 2 elements, again you sorted हो भी सकता है नहीं भी हो सकता, I don't know. So you start comparing that ith element is the last element. You take out that element and you start comparing with all element after that. Hey, what I see that 6 is greater than 4. If 6 is greater than 4, shift 6 and then again you say j minus minus. As you say j minus minus, hey, what happened? J minus minus, that j is greater than or equal to 0. This condition is false. If this condition is false, you come out of the loop and then you try to insert this element after this. That's it. It's over. But this was an array of 2 elements. Wait for a minute. Wait for a minute and now you continue further. What do you continue further? Now you consider that your array is not of 2 elements. Now you consider that your array is of 3 elements. Now you consider that array is of 3 elements. Please note that the earlier array is already sorted. If earlier array is already sorted, now again I'm saying you consider I is equal to 2 now. You consider I is equal to 2 now, and again you start comparing with all elements before that. Okay, how do you start comparing all elements before that? Let us again take it over here. Let us take this element out. Let us take ith element out. You compare with. I realize that 6 is greater than 2. Shift it. 4 is, then compare with 4. Compare with 4. 4 is also greater than 2. Shift. Again you go out. Now you find that there is no element to compare. Put 2 over here. That's it. And this is nothing but my array is once again sorted. Now the array of 3 element is sorted. Array of 3 element is sorted. Sir, अब आगे क्या करना है? कुछ नहीं, repeat the procedure. Why don't now you consider that you have got array of 4 elements. Now go ahead, consider you got array of 4 elements. You got array of 4 element. The last element, the unsorted element, let's say I is equal to 3. You take out the element. You take out the element in a temporary variable. You take out the element in a temporary variable and you start comparing all elements before that. You start comparing all elements before that. You realize that the 6 itself is smaller than 8. 8, if 6 is itself is smaller than 8, what is to be done? What is to be done? I want to add the element after that. Oh, you go ahead, you add the element after that, like 6, 8. So nothing much to be done. So you find that now this is already sorted. You continue further. You continue further. Now you consider the array is of 5 elements. You consider your array is of 5 elements, not 4 elements. Your array is of 5 elements. And the last element in this particular case, I can say I is equal to 4 now. Now you again continue and you compare with all elements before that. So temporary variable, you take it out. You start comparing. I found that, oh, 8 is greater than 3, shift it. 6 is greater than 3, shift it. 4 is greater than 3, shift it. 2 is not greater than 3. What is to be done? Very simple. Put 3 after 2. Put 3 after 2. And again, this much array of 5 elements is sorted. Last pass. Last pass, you consider you have got an array of 6 elements. You consider array is of 6 element. The sixth element is, let's say, 1. So at a time, we are not looking at the whole array at all. We are not looking at the whole array at all. You take it in a temporary variable where it was like I is equal to 5, and you start comparing with all elements before that. You compare with 8, 8 is greater. You compare with 6, 6 is greater. You compare with 4, 4 is greater. You compare with 3, 3 is greater. You compare with 2, 2 is greater. And then you reach to the -1. There is no element to compare. Just put this over here. And that's it. This is what all you call it the insertion sort. So what is the insertion sort? The insertion sort is very simple. You start from I is equal to 2, sorry, I is equal to 1 till I is equal to 5. Consider every time the ith element is the last element. Ith element is last element. Compare with all element previous to that and follow the insertion technique on that. You call it as the insertion sort. You call it the insertion sort. Don't worry. If it is not clear, I'm repeating it once again. I'm going ahead. I'm repeating it once again. That is the reason I was saying that please focus on insertion technique first. Do not worry about the sorting technique later. क्योंकि अगर आपको insertion समझ में आ गया है, now you are just, what you are doing, you are applying insertion 5 times. First with the array of 2, then with the array of 3, then with the array of 4, then with the array of 5, then with the array of 6. That's it. Nothing new that you are applying over here. And that is the reason I said, अगर आपको insertion समझ में आता है, insertion sort is very easy. Very easy. It is that simple. Chalo, go ahead. I'm repeating it once again for you. I'm repeating it once again for you. What I'm saying, you consider initially array is of 2 elements only. Array is of 2 elements only. And obviously, agar array is of 2 elements hoga, so I is equal to 1. I is equal to 1 will be like a smallest, what is that? Will be the last element. हम लोग पूरा array देख ही नहीं रहे, हम लोग सिर्फ 2 का array देख रहे हैं. तो हम लोग कह रहे हैं कि I is equal to 1 that is my last index. If that is my last index, you take out 4, you take out 4, and you start comparing with all elements before that. You start comparing with all elements before that. Okay, that is good. You find that 6 is greater. अभी हम लोग insertion technique follow कर रहे हैं with the array of 2, 4 is taken in a temp, and then you are following the technique. So you find that 6 is greater than this, you shift this, and there is nothing to compare. There is nothing to compare. You want to insert this at the location 0. Done. So now my array of 2 is sorted. Array of 2 is sorted. Let me continue further. Repeat the same process. Now repeat the same process for array of 3. Now let us focus on array of 3 where we have got 3 elements, and at this moment I can consider that this element, I can consider that this element is not sorted. If this element is not sorted, what is to be done? Take out this element, take out this element, and start comparing with all elements before that. So you find that 6 is greater, shift that. 4 is greater, compare with 4. 4 is greater, shift that. There is nothing to compare. Or nothing to compare, you insert 2 at the 0th location and you continue further. Just now you sorted array of 3. You sorted array of 3, you continue further. Let us consider the array is of 4 elements. If you consider arrays of 4 element, the 4th element was nothing but 8, and you say I is equal to 3 over there, and you start comparing. Again, you take one element out, you compare with all elements before that. I hope आप लोगों को समझ में आ रहा है. You compare with all elements before that. पहले दूसरे इटरेशन में नहीं भी समझ में आया, तो इसीलिए तो हम लोग एक एक चीज के हम लोग चार चार इटरेशंस, पांच पांच इटरेशंस कर रहे हैं, so that you can see the same iteration is getting repeated again and again. I'm saying that this is the last element of the array, and compare with all elements before that. So you start comparing, you find that 6 is greater than 8, shift. 4 is greater than 8. No, sorry, my mistake. 6 is not greater than 8. 6 is not greater than 8. So you find that in this particular case, 6 is smaller than 8. So you want to simply add the element after this. Okay, that is also done. So यहाँ पर 8 के लिए आपको internal सारे passes करने की जरूरत ही नहीं पड़ी. Oh, that was easy job. You continued further, and now you consider array of array of 5 elements. Which is the fifth element? Fifth element is 3. You copy that. It is added over there. मैं आपको उतना ही array दिखा रहा हूं. I'm just saying that you focus only on that part. So here I is equal to now 4. I is equal to now 4, and you take out that element. Whichever is the last element, you take it out and start comparing with all elements previous to that. 8 is greater, shift. 6 is greater, shift. 4 is greater, shift. And then you find that there is nothing. 2 is smaller. 2 is smaller than 3. So you want to insert it at the place. Done. Finally, we have got array of 6, जो कि अपना original array था, his array of 6, and the element that was there was, let's say, 1. Again, I am considering that this was the element which is like unsorted. If this is element unsorted, I is equal to 5, and then you continue the process. You take out 1 in a temporary variable, start comparing. You find that 8 is greater, shift. 6 is greater, shift. 4 is greater, shift. 3 is greater, shift. 2 is greater, shift. Nothing to compare. You put in 1 at the appropriate location. Is this clear? I guess that is what algorithm is. That's why I was saying that just focus on a basic part first. Basic part first, advanced part will automatically done. So how do I change this code? Very difficult or not at all? Changing this code is very easy job. Please pay attention for ये कहां से आई शुरू करना है, आई शुरू कहां से करना है, कहां से कहां तक आई रिपीट करना है. टेक अ लुक एट द पेपर. 1 से लेके लास्ट इंडेक्स तक. एम आई करेक्ट? 1 से लेके लास्ट इंडेक्स तक. So I is equal to 1. I is less than AR dot length I plus plus. Okay, that is good. and each time we are saying that it is the last element of the array. If ith element is the last element of array, please pay attention. Ith element is the last element of array. Done. If ith element is the last element of array, the element before that, a ith element se pehle, I minus 1, I want to compare till last element, j is greater than equal to 0, and j, every time you are doing a shifting, that is done, it's over. Nothing much I need to do. Nothing much I need to do. So is it sorted? Yes, it is sorted. That is what you call it as a insertion sort. That is what insertion sort. What we are doing is that over here we say that n minus 1 passes. N minus 1 passes, and in each pass, consider ith element as last element of array. Last element of array. Then compare or copy last element into temporary variable, compare temp with all elements before that, find appropriate position for the element, and insert into the insert temp at that position. And that is what we have done, kind of insertion technique. That's it. Janvi ka kuch question hai? Why I is not why not I is less than error dot length minus 1? Janvi, take a look at this. Initial value is I is equal to 1. Last value is equal to I is equal to 5. The array is of total 6 elements. Array is total 6 element. So 6 minus 1 is equal to 5. That's it. This is what all I'm looking for. यहाँ पर मैंने क्या लिखा है? AR dot length लिखा है. A length लिखा है, मतलब ये कहाँ तक जाएगा? Till n minus 1 तक जाएगा. अगर आपको length minus 1 लिखना है, all I need to do is that, अगर आपको length minus 1 लिखना है, all I need to do is to use less than or equal to sign. क्योंकि ultimately my aim is that I want to consider even the last element as an unsorted element. यहाँ पर पहला एलिमेंट एज अनसॉर्टेड कंसिडर करना है, उसके बाद में इसको अनसॉर्टेड कंसिडर करना है, फिर इसको अनसॉर्टेड कंसिडर करना है, फिर इसको अनसॉर्टेड कंसिडर करना है, फाइनली इसको अनसॉर्टेड कंसिडर करना है. Isn't it? Even last element is to be considered, right? And that is the reason. But ये लिखने से ये ज्यादा अच्छा लगता है. Done? Okay, that is good. सर ये काम करता है क्या? ओ काम करता है क्या? That is a question. पहले करके देखते हैं. Insertion sort ARR. I guess कुछ लोगों ने करके देख लिया है. And you find that yes, my array is still sorted. My array is still sorted. I hope everything is all right. Why don't you try it at your end? Go ahead. By the way, if at all you are finding that I'm going too slow, let me know that as well. Good. So we started talking today about this. Yes, Pooja. No, I'm not actually talking about that. So there are few people in your batch which are like, extra intelligent, and then they usually keep saying that I should take simple topics at bit faster rate. So if you really want I should go fast, please tell it on a common platform, so that really everyone will accept it. If everyone accept it, I really don't have any problem. We can always speed it up. So at the end, at the end of the module, say that नहीं sir, sorting थोड़ा fast पढ़ाना चाहिए था. So if you want, just tell me on a day one itself and tell it in front of all the class. Not like, tell me personally, sir, you are going too slow, please increase your speed. Let us go with the class, not for like one individual. Error of z plus 1 temp in an inner loop, still it work? Yes, it is. But then again, Namrata, why are you doing that? Let us understand algorithm and then do it, not doing a trial and error, isn't it? Okay, that is good. Chalo. So we have completed the bubble sort, we have completed insertion sort. अगर आपका algorithm हो गया है, what about the time complexity of this algorithm? Oh, I want to study that as well. A time complexity of that algorithm. Chalo, go ahead, compare it. How many maximum iterations are happening in like a first pass? How many maximum iterations are happening in a first pass? Have you noted? पहले पास में कितने iterations हो रहे हैं? What we are doing? We are comparing this element with all elements before that. One iteration, yes, correct. And then in a second pass, there will be two iterations. In a third pass, there will be, let's say, three iterations. And the next pass, there will be, let's say, four iterations. And the next pass, there will be, let's say, five iterations. So number of iterations that are happening in each pass, maximum iterations I'm talking about. I'm not saying total number of iterations, क्योंकि अगर आप लोगों ने ठीक से नोट किया, in this case ये वाला अगर आप लोगों ने एग्जांपल चेक किया था, यहाँ पर 8 हम लोगों ने बाहर निकाला और immediately अंदर डाल दिया. In this particular case, even none of the earlier iteration was done. I'm just saying that the maximum number of iterations whichever are possible are hardly, अगर आप लोग इसको प्लस करते हो, like a 15 iterations. So I guess the formula is pretty simple. The number of iterations, total number of iterations are nothing but it is 1 plus 2 plus, you continue further on each iteration up to n minus 1. And if this is arithmetic progression, you know the answer of that as well. So number of iterations are still n into n minus 1 by 2. I hope you got that. And if it is so, this is exactly same as of selection sort or kind of improved bubble sort that we have seen earlier. I can simply say that the time required is proportional to n square minus n. 1 by 2 is constant, you take it out, and then the time complexity comes out to be O n square only. If you people have really understood this, I want you people to try it one more on paper. Try it one more on paper. And what to try? Please try it. What if your array is already sorted? Take this array and do it on paper and count how many iterations of the inner loop are done. Count how many iterations of the inner loop are done in each pass. In each pass, how many iterations of the inner loop are done? बहुत सारे लोगों का प्रोग्राम करके हो गया है. I said that you are already ready with the paper and pencil. Take this and again you need to follow the same logic. क्या करना है? You need to take this element out, compare with all previous element, find the appropriate position and put that element back to the place. This is what all you need to try it. So Malika, I guess you are talking about five iterations in all passes together, right? So one for each pass, absolutely correct. One for each pass, total probably 5. So you find that in this particular case, take a look at this. You take 2 out, but you find that this element itself is greater. So you want to put it in a place. Your first pass is completed. Then you take this out, you compare with all previous element, but again you find that this element itself is smaller, you put it back to the place. You take this element out, you find that the previous element itself is smaller, you put it back to the place again. Then you again find out that this element is 1, so again you put it back to the place, and again you take this element out, and again you find that this element is smaller, again you put it back to the place. So you find that the inner loop probably hardly one iteration is done. So what is the time complexity in this case? In this case आपका inner loop वैसे भी execute हो ही नहीं रहा है. So you find that the total number of iterations will be directly proportional to the number of elements, and then the time complexity is of order of n. By the way, हम लोग ये क्या पढ़ रहे हैं? What is this? जो भी पढ़ रहे हैं उसको क्या कह रहे हैं? Yes, special case, like a best case. The best case time complexity for your insertion sort will be O of n. That's it. So this is all about kind of sorting algorithms, basic sorting algorithms. There are three more left, like heap sort, merge sort, quick sort, that we will see it sometime later. When you are like more comfortable with the recursion and all that, at that time we will talk about that. You have got any question regarding sorting? Whatever we have learned so far, this is like good time to ask.